वेलकम टू बिटूनेट कोड चैनल। गाइस, आज के सेशन में हम देखेंगे रैपिड स्पैनिंग ट्री प्रोटोकॉल। So this rapid spanning tree protocol was designed as a uh, consequence of few shortages in spanning tree protocol. Right, चलिए start करते हैं rapid spanning tree protocol, that is also called as RSTP. Guys, STP standard is 802.1 and D, and rapid spanning tree protocol standard is 802.1 W. So guys, this was started to address the shortcomings of 802.1D. The 802.1D spanning tree protocol was designed at a time when the recovery of connectivity after an outage with a minute or so was considered adequate performance. With the advent of layer 3 switching in LAN environments, bridging now competes with routed solutions where protocols such as OSPF and EIGRP are able to provide an alternate path in less time. So, guys, these are the switches that support RSTP. Okay, and we have multiple spanning tree protocol also that we will discuss later on. So right now the session is on rapid spanning tree protocol RSTP. तो गाइज हमारे स्पैनिंग ट्री प्रोटोकॉल में 5 पोर्ट स्टेट्स होती हैं 802.1D में. वन इज डिसेबल्ड, लिसनिंग, लर्निंग, ब्लॉकिंग एंड फॉरवर्डिंग. Okay, and if we compare these port states to RSTP port states, तो RSTP में हमारे ये जो फर्स्ट 3 पोर्ट स्टेट्स हैं, disabled, blocking, listening, these are combined into one and they are called a discarding. Okay, so that's why the convergence type of RSTP, convergence time of RSTP is reduced a lot. तो ये चेक कर लेते हैं. देर आर ओनली 3 पोर्ट स्टेट्स लेफ्ट इन RSTP दैट करस्पॉन्ड to 3 possible operational states. 802.1D is disabled, blocking, listening states are merged into unique 802.1W discarding states. तो STP में disabled state में port include in active topology no, blocking में no. Okay, and listening, learning, forwarding में port is included in active topology. And MAC address learning, it doesn't happen in disabled, blocking and listening, whereas it happens in learning and forwarding only. तो चलिए देख लेते हैं ये पोर्ट रोल्स. The port that receives the best BPDU on a bridge is the root port. For example, this switch is our root bridge. Okay, and these are the access layer switches. तो हमारे जिस पोर्ट पे बेस्ट BPDU आएगा, राइट, दैट विल बी द रूट पोर्ट. तो नेक्स्ट पोर्ट ब्लॉक हो जाएगा. So this is the port that is closest to the root bridge in terms of path cost. The STA elects a single root bridge in the whole bridge network per VLAN. The root bridge sends BPDUs that are more useful than the ones any other bridge sends. The root bridge is the only bridge in the network that does not have a root port. All other bridges receive BPDU on at least one port. तो गाइज रूट पोर्ट के सभी इंटरफेसेस डेजिग्नेटेड पोर्ट होंगे. ओके, और स्विच का that gets the best BPDU that will become the root port and other will become the alternate port or block port. So with the help of alternate port or block port, STP controls the loop in the network. And alternate port is also called backup port, that is used in case of the primary in case of the root port goes down, then backup port comes up and it becomes the root port. तो गाइज RSTP में जो नया BPD यूज होता है वो देख लेंगे. Few changes have been introduced by RSTP to the BPDU format. Only two flags, topology change and topology change acknowledgement, are defined in 802.1D. However, RSTP now uses all 6 bits of flag byte. तो गाइज ये बीपीडीओ में ये जो 8 बिट्स का बीपीडीओ होता है उसमें सिर्फ दो बिट्स यूज़ होते हैं. वन इज़ फॉर टोपोलॉजी चेंज एंड नोटिफिकेशन एंड अदर इज़ फॉर टोपोलॉजी चेंज नोटिफिकेशन एक्नॉलेजमेंट. ये बीच वाले बिट्स एसटीपी में यूज़ नहीं होते हैं, राइट. So these are used by RSTP. So these are the purposes for which RSTP uses these 6 bits. So first is used for proposal, okay, and third is used for to define the port role. Port role are unknown, alternate or backup. If its value is 1, if its value is 10, it will be considered as root port, and if its value is 11, it will be considered as designated port. Then the next flag is used to tell if it is learning MAC addresses, and this fifth bit is used for forwarding, and sixth bit is agreement. सो हमारे आज के सेशन में हम डिस्कस करेंगे ये प्रपोजल एंड एग्रीमेंट बिट्स. ये क्या होते हैं एंड व्हाई दे आर यूज्ड एंड हाउ दे आर यूज्ड. दिस प्रपोजल एंड एग्रीमेंट bit that are used in the BPDU flag along with the topology change notification 0 bit and this topology change notification acknowledgement. तो गाइज ये है हमारे BPDU का फॉर्मेट. तो मैं इसको नेक्स्ट में खोल लेता हूँ. तो ये है हमारा फ्रेम एंड इन दिस फ्रेम इफ वी गो टू द BPDU, राइट. तो BPDU में हमारा दिस इज द BPDU, ओके, एंड दिस BPDU में जो ये फ्लैग्स होगा, राइट, दिस फ्लैग विल बी used by RSTP. STP only use 2 bits, one for topology change notification and one for topology change notification acknowledgement, whereas RSTP uses all the 6 bits. तो जो 6 बिट्स की वो वैल्यूज़ होंगी वो ये होंगी. 1 इज़ फॉर प्रपोजल, 2 and 3 इज़ फॉर पोर्ट रोल, 4 इज़ फॉर लर्निंग फॉरवर्डिंग, 6 इज़ फॉर एग्रीमेंट एंड 7th इज़ टोपोलॉजी चेंज एक्नॉलेजमेंट. तो ये है हमारा RSTP का फ्लैग यूसेज. और ये STP में स्पेनिंग ट्री प्रोटोकॉल 802.1D में these all flags are unused. So it uses only 2 bits, 0 bit for topology change notification and 7th last bit for topology change acknowledgement. तो गाइस हम चलिए वापस चलते हैं. तो RSTP में जो BPDUs है, the BPDU time is 2 seconds, right. It is similar to STP, whereas the aging time in STP was 20 seconds, and in RSTP it is 3 times of hello time, that is 6 seconds for RSTP. तो ये हम देख लेते हैं. For example, this is our network, out of which this is the root bridge, okay, and this is the root port, okay, and this is also the root port, this is also the root port. In case this link is broken, okay, now this root port cannot connect to the root bridge. So in that case this switch will use this port. Earlier this port was in blocking stage. When this it will detect that BPDU is not coming from root bridge, it will enable this port, alternate port, and will make it a root port. So now BPDU will come through this switch, because it is now receiving BPDUs from inferior BPDU will go from this port, and it will receive superior BPDUs from this path. Okay, so now this port is down and this port will become a root port. So how transition, rapid transition happen in RSTP, ये अभी डिस्कस करेंगे. Edge ports, guys. Edge ports are those ports that have a post port fast feature enabled, and STP does not run on those ports, right? So they come up very quickly. They do not go through STP states of forwarding and learning, and we normally connect end devices to the edge ports. तो हमारा मेन डिस्कशन है 802.1W पे, तो इसकी हम ये पोर्ट स्टेट्स देख लेते हैं. Actually what I wanted to show you is the agreement proposal. Yeah, this is the main thing I want to show you. When a port is selected by STA to become a designated port, 802.1D still waits twice forward delay seconds before it transitions to forwarding states. तो नॉर्मल एसटीपी में हमारा जो पोर्ट है अप आने में 30 सेकेंड्स लग जाते हैं. 15 फॉर फॉरवर्ड डिले एंड 15 फॉरवर्ड डिले सेकेंड 2 into 15 बाय डिफॉल्ट. तो आरएसटीपी के केस में ये बहुत क्विकली हो जाता है. So whenever we enable RSTP on two switches, हम अभी डेमो में देखेंगे इवेंट जी में कि how these three the port states are skipped. So first of all, whenever we enable RSTP on any switch, okay, every switch will consider all its ports as a designated port initially, right, and will switch and will send an a proposal to other switch. So for example, this is the root bridge. We have enabled RSTP on this root bridge. Now it is considering itself as a root bridge, and all its ports are in DP designated port. So it will send proposal to the neighbor switches that this is I am the root bridge. So and other switch will receive the proposal. If it sees that the bridge ID of the root bridge is better than my bridge ID, it will send the agreement that yes, I agree that you are the root bridge. I will make my port as the root port. Okay, this way transaction happens, and while this is process is going on, this switch A will make its other port as in blocked port, so that no data transmission can happen at that time when it is doing agreement proposal with other switch. So these three ports will be blocked. Okay, and when RSTP is enabled on this link, and this is a root bridge and this became the root port, then it will turn back these ports on, and they will be disabled for few milliseconds, and then while this synchronization is going on, and then when this process is over, then these ports will be turned on. यहाँ पे देख लेते हैं. When a designated port is in discarding or learning state, and only in the case it sets the proposal bit on the BPD it sends out. This is what occurs for port 0 of the root bridge as shown in step 1 of preceding diagram. Because root switch A receives the superior information, it immediately knows that P1 is the new root port. ये root port बन गया हमारा. Switch A then starts a sync to verify that all of its ports are in sync with this new information. A port is in sync if it meets either of these criteria. The port is in a blocking state, which means discarding in a stable topology. The port is an edge port. तो गाइज ये RSTP में ये अपलिंक फास्ट एंड ये बाय डिफ़ॉल्ट इनेबल होता है. दिस इज़ हाउ इट बिकम फास्ट कन्वर्जेंस. तो ये हम अभी सारा प्रैक्टिकल करके देख लेते हैं इवेंट जी में. तो चलिए मैं ये सारे डिवाइसेस को ऑन कर देता हूँ. लेट्स टेक access of switch 1. And let's go to switch 2. let's go to switch 3. And let me show you IP address is configured. So this has the IP address as 10114, this PC4, and this PC5 has IP address as 10115, right? So right now they can talk to each other. Ping, let's check. Okay, they can talk to each other. Let's go to switch 1. Do show spanning tree. Now switch 1 के सभी ports forwarding stage में है, and all are designated, all are DP, and there is no root port in on switch 1. That means switch 1 is the root bridge, and we can see here also it says this bridge is root. Okay, and the MAC address is this one. So priority of every switch is 32768 by default. For VLAN 1 it becomes 32768 plus 1, 32769. So this is the root bridge because it has the lowest MAC address. And let's go to switch 2. We can see that the priority of this switch is also same. Okay, but it has different MAC address 2000. That is why it could not become the root bridge. And here we can say that the address of root bridge is 1000. तो switch 3 की configuration भी देख लेते हैं. Here also it considers 100 as a root bridge, and this is the MAC address of this root bridge. Guys, here we can see that E0 port is the root port, right? Like here, this is the root port, and this is the block port. E01 is blocked here. This port is blocked, right? That is why loop is not forming. This is the root port. These two are the DPs of switch 2. Let's go to switch 2. We can see that root port is E00. This is the root port, and block port is E10. This port is blocked, right? Let me mark it from here. This port is blocked. This port is blocked. Okay, and these are the DPs. These these are the DPs. This is also DP, and this F10 is E10 is blocked. E10, this is blocked, right? And root port is E00. This is RP. And if we go to switch 1, all the ports for switch 1 should be DP. They all are in a designated mode. This is DP, and this is also DP. So we can see from switch 1 configuration all the ports are DPs, right? So this way our loop is not forming in this configuration. Let me show you these concepts from here also. Like here we can see that, see, for example, this is our network. When we enable RSTP on this switch, okay, or this switch, so both will switches will send proposal to each other by making their ports are designated ports. So we can see that first of all, proposal will be sent, and second step will be synchronization. So this switch will block both these ports, okay, and while this is synchronizing proposal agreement process with this switch, okay, if it finds that BPDU coming from this switch is superior, it will make its port as a root port, and then it will send back agreement. First agreement, then synchronization, then third will be blocking the port, okay, then fourth agreement will be sent, and then fifth will be forwarding, and then it will also send a forwarding, it will go into forwarding stage, right? Now this switch is in forwarding stage, this switch is also in forwarding state. So this proposal agreement has completed between these two switches. Now the proposal agreement process will start between these two switches. So both of these switches will send proposal to each other, and they will both will consider themselves a root, okay, and they will decide which will become the root bridge. So whichever switch gets the superior BPDU from other, that switch will accept the proposal and will send the agreement back. So here in this case, this switch received a superior BPDU from this switch because it sent the superior BPDU that it received from this switch. Okay, so this switch superior BPDU sent here, then it is sent here. So it also sent the agreement. It received the proposal, then it sent agreement in seventh stage, and eighth stage became the in forwarding stage. So this is the sequence of event during RSTP. So the same process happen when switches are connected to each other. Proposal, first of all, proposal come, these ports go into blocking stage, okay. When this proposal agreement stage completes, okay, then it then this switch now will do proposal agreement with these switches, okay, then it will send proposal. We can see this is the proposal going, and then agreement is getting back, right? So proposal, agreement. While this process is happening, this process is happening, proposal is going, agreement is coming back, okay, these are blocked, okay, these are blocked, these ports are blocked while these two switches are synchronizing with this switch, okay. So this is getting proposal, and this switch is sending agreement. Okay, so when this steps complete, okay, then the switches will go to next stage. Now these switches will negotiate with other set of switches. The same process is repeated, and this way RSTP synchronization happen throughout the network. So we will discuss this in EVNG shortly. So let's go to EVNG. Okay, now we are on the switch 1. Right now we can see that STP is running on these switches 802.1D, right? So let's do one thing before enabling RSTP on switch. Let's enable BPDU debugging on switch 1. Sorry, not we will enable spanning tree events only, right? Because this will be a lot of information. So let's go to RSTP and enable spanning tree mode rapid PVST, right? This is RSTP per VLAN rapid spanning tree mode. Okay, now we have enabled debugging, so let hit enter. Okay, now we can see that all its ports are switch 1 ports are going into DP mode, and it is sending the proposal, right? This is the proposal that is going through all its ports. And do you all okay, now let's see. Switch is initializing port Ethernet 0/0. E00 is now designated. E01 initialize. E01 is also designated, and 02 is also designated. So switch 1 make all its ports as a designated, and it starts sending the proposal from all its ports. We can see here it is sending a proposal from all the ports because we have enabled RSTP. Okay, in EVNG there is a bug in EVNG. We don't get agreement response here. Okay, so if we check this on real devices, we will be able to see that. Now let's see spanning tree. Now we can see that RSTP is enabled, and it is the root bridge. Now let's go to switch 2. Here, right now here STP is running, and now we will enable RSTP on switch 2 also. uh, Debug spanning tree events. Okay, spanning tree mode rapid PVST. Now you will see that this switch will also make all its port as designated. Okay, let's see. uh, Switch 2 has a 0 port and 10 connected to the root bridge switch 10. Initializing port E00. E00 is now designated. Initializing port E01. E01 is designated. So this switch also made all its ports as designated. When it made its ports as DPs, then it started sending proposal, or see, transmitting a proposal on all its ports. Okay, and update roles. It received the superior BPDU on 10. Okay, so it received superior BPDU on this one. Update roles received superior BPDU on it E00. So it received superior BPDU on E00 and E10. So both these ports, from both these ports, it received superior BPDU. So that means it updated the roles of the ports, and it made the E00 as the root port, and E10 blocked by reroute, right? 10 is blocked, and E00 is now root port. We can see here, and while this is synchronizing it blocked these ports E01, 02, 03, 11. Other ports will be blocked, while this is synchronizing agreement and proposal with switch 1, right? And in the meantime, when it was doing agreement proposal, proposal was sent from all the ports, right? But root port has been configured as this one E00. Now see spanning tree. Now RSTP is running on this port also, and here it says peer STP. STP is running on 01 and 11. That means on this port, these ports are still running traditional STP. Okay, the meaning of this shear peer shared peer is STP. Okay, whereas on rest of the ports it is running RSTP. So we will enable RSTP on these ports also. So we can see that one port is alternate, one is root, rest are designated. So now let's go to switch number 3. Spanning tree mode, rapid PVST. We can see that this also made all its ports as designated, and then it started transmitting the proposal from all the ports. Now when it will receive superior BPDU from one of its port, from this port, okay, it will make its port as root port, and rest of the ports will be blocked, and this will be alternate port. Let's study details of agreement and proposal on this switch. Here we can see that. Let me do one thing. Let me drag it little bit towards left hand side, so that we can see everything properly. Now see E00 designated for switch 3. Okay, E01 designated. All other ports that are in this picture, they are not connected, but it will make all the ports are designated, and will start sending proposal from all the ports. And here have a look at this line. It received superior BPDU on E01. Okay, and E01 is now root port, but it also received superior BPDU on E00. E00. Okay, so E00 became the root port. Okay, and E01 is blocked by root, by reroute. Okay, so all other ports went into sync mode. That means they are blocked for a short while this agreement proposal process is happening, and RSTP is synchronizing. So this way RSTP is enabled on this switch also. Let me show you, show spanning tree. We can see that RSTP is configured on this switch also, and it accepted 100 as root ID. This switch has the root bridge. Okay, and now we can see that it has a root port in forwarding. E00 in is the root port. Alternate block port is E01, and rest all are the DPs for this switch. Okay, and it doesn't because it is not having STP running anywhere, so it is not showing STP. Let me go back to switch 2. Earlier it was showing peer STP. So let's give this command again, and now we can see that that command is gone, right? Because now RSTP is running on all these three switches. Earlier switch 3 was running traditional STP, that's why it was showing as STP. Now switch 3 is running STP on all its ports, and switch same with switch 2 and switch 3. So guys, this was the डिस्कशन अबाउट रैपिड स्पैनिंग ट्री प्रोटोकॉल. आपको ये वीडियो कैसा लगा मुझे कमेंट सेक्शन में बताएं. एंड इन केस यू लाइक दिस वीडियो, प्लीज़ डोंट फॉरगेट टू like button. And before we wrap up this video, I'm sorry, I forgot to show you one thing. Let's have a look at the packet capture also. This is the packet capture I have downloaded, and I want you to see, have a look at this for a while. यहाँ पे हम देख लेते हैं, ये स्पैनिंग ट्री हमारा चल रहा है. ओके, ये देखिए मल्टीपल स्पैनिंग ट्री और MST ऑल्सो यूजेस रैपिड स्पैनिंग ट्री प्रोटोकॉल. तो यहाँ पे जो फ्लैग्स हैं, राइट, वो देख लेते हैं. ये देखिए इस पैकेट में टोपोलॉजी चेंज एक्नॉलेजमेंट, ये जो फ्लैग हमने डिस्कस करे थे, these flags, right? Topology change bit 0, right? Here it is 0 because this is not topology chain acknowledgement. And if agreement is happening, then agreement second bit will be on. This is on. It is third bit is in forwarding stage, fourth bit is learning stage. Okay, and the next two bits are 1 1, both are on. They are showing designated. Is it sending proposal? No, because agreement is being sent, so proposal is not, right? Either agreement will be done or proposal will be done. So this is not the topology change notification, so that's why topology change bit is off. Acknowledgement is also off. So here forwarding agreement is being sent. Okay, that's why proposal is 0. तो यहाँ पे हम देख लेते हैं रूट आइडेंटिफायर 32768 बाय डिफ़ॉल्ट, रूट ब्रिज प्रायोरिटी 32768, रूट की रूट पाथ कॉस्ट 0 होती है अभी तक, तो प्रायोरिटी 32768, हेलो टाइम 2 सेकेंड, फॉरवर्ड डिले 15 सेकेंड. तो ये MST का है, दैट्स वाई हियर आर द MST डिटेल्स. दीज MST आई विल डिस्कस इन नेक्स्ट सेशन. तो एक बार इधर भी देख लेते हैं, ये रैपिड स्पैनिंग ट्री का पैकेट है. तो गाइज यहाँ पे हम देख सकते हैं, हियर एग्रीमेंट इज नॉट हैपनिंग. ओके, लर्निंग इज नॉट हैपनिंग, ऑल दिस बिट्स आर ऑफ. पोर्ट रोल डेजिग्नेटेड, प्रपोजल इज बीइंग सेंट, प्रपोजल जा रहा है इस पैकेट में, राइट? ये जो पोर्ट पैकेट कैप्चर हुआ, तो ये गाइज ब्रिज आइडेंटिफायर, तो ये हेलो टाइमर, फॉरवर्ड डिले एंड वर्जन 1 इज बीइंग यूज. तो गाइज ये था हम प्रपोजल एग्रीमेंट फ्लैग्स जो RSTP यूज़ करता है, राइट? दिस. तो गाइज ये आपको वीडियो कैसा लगा मुझे कमेंट सेक्शन में ज़रूर बताएं. थैंक यू फॉर वॉचिंग दिस वीडियो.